Okay, guys, welcome back. So we have covered several different things that you can do to improve a model. So my next request for you, homework, is the following. I think it could be a good idea for you to use a new data set and create a model for that data set that have a good performance, right? So two things. Using a new data set is going to allow you to practice. Moreover, it's going to allow us to review all the things that we have covered. Homework is going to open today. You're going to have the link on Canvas at the end of the lecture with more details. I am going to talk about it during the lecture. But basically, what I am going to ask you to do is to create 4 models, 3 models, one that is good, one that is bad, and another one in the middle for this new data set. Make sense? Clear. The goal, again, for you to practice the things that we have reviewed, the decisions that you can do. In particular, I am talking about for you to take the decision of which activation function to use, the error function that you're going to use, how you're going to initialize the W's, if you're going to use updaters or not. And one more thing that I need to talk with you today about the epochs. As usual, I am asking you for the models, but also I want you to create a paper and explain in the paper your decisions and the results. The goal of the paper is for you to submit not only the source code, but an explanation of what happened. Clear? You're going to have 1 week, is open today, it's going to be due next week, and the details on Canvas. As usual, please, if possible, submit a PDF or a doc file, so it could be easy for the grader to read and review. Now, one thing that I need to cover from that list, the epochs. Let's see. Summary, things that you're going to use, something that we already covered. Initialization. At least you have 2 options, uniform and the Xavier one. Probably they are going to be good options for you to create a good and a bad model. You can at least play with 1 and 1. Difference between them, as you remember, the second one is the one that is going to be random with particular limitations, but it's all about the W's at the beginning be a constant, all the same, or be different values in a good way. Activation function, I showed you this picture long time ago from this one, something that now we cover, something that now you understand, you know, at least we use the sig mode and we use the ReLU. And at least it is clear what happened here, plain, versus what happened in the S. And at least we already reviewed 2 models in which that one was not the best option. However, we used that one before and worked perfectly well. I would like you to tell me which one of those you are going to use. But moreover, in the data set that I am going to ask you to use, if you look online, I am sure that you're going to find the correct optimal solution. Please, I am asking for 3 models. If you want to use the very best one and you are going to research online, okay, just be sure to explain the things and just be sure to avoid academic integrity problems. Anyway, if you search online, you're going to notice that for the particular data set, the best activation function is neither this one or that one, at least not for the hidden layers. So an opportunity for you to learn about a new one, but that one is very close to the one that is the optimal. So the sig mode could give you very good results, even though not the top ones. You can keep yourself working with the two that we covered here, or you can adventure in new approaches. You're going to find similar ideas. Anyway, those at the top for the hidden layers. One that is going to be a constant, yet for the new data set, I am going to add you for probabilities, for predictions. And when you're looking for probabilities and predictions, still, this one is going to be a good option for the output layer. So a good one, but you can try with any of the others, or the sigmode for the bad option. Even you can keep this one for the bad option. You're going to notice what happened. Clear, right? The activation functions. Professor, all of them exist in the library that we're using? Yes. And I am pretty sure that you can guess the names. You just put uppercase the names and it's a constant there. Easy. Now, other thing that you can use is the error function. That is not the same as the activation one. For the error function, basically we have been using these two. My only recommendation, you want to play with this. If you are using softmax in the previous one, if you are moving to probabilities in the hidden layers, the output, likelihood, probabilities with probabilities. You can play and see what happens when you use probabilities with MSE, or the opposite, sigmode with likelihood. It's not going to be good. The rule, the second one, is going to help you to create a better model, for sure. That is going to be a constant, because the problem is going to be about probabilities. Now, the operators. We cover quickly, very quickly. One, the basic one, the gradients, the derivatives. The simple, obvious one that is going to be there without you doing anything is my first equation there. The one in which we are going to establish a learning rate, that is the constant and modified equation. That one is going to be simple. It is good for some things, not exactly the one that is going to be the best one. It's going to be or could be something in the middle or something bad. But for the problem that we're going to use, probabilities, I am sure that you can use one of the others. The learning rate adaptive. Adam. The momentum thing with the speed for the values. Nesteros. Or the combination of both. Nadam. The 3, the 4 available in the library. Play with them while solving the problem. You can expect this result. Any of the last 3 is going to give you an improvement compared with the default one. That is something that you can expect as we reviewed before. Good? Okay, moreover, okay, the equation, the initialization, the activation, the layers. I give you this example before. We play basically with one hidden layer in total. If you remember, we play with one that have 1,000 nodes in one. You have this example with 2. We review it. Okay, you can have 2 dense and 1 output, 2 layers, input, 2 hidden layers, the output. You can create several of them. I invite you to play with them. You're going to notice adding more layers is usually something that is not going to increase or decrease the performance in a significant way. Not for most of the problems, not for the one that I am going to ask you to solve. Your solution with 1 layer could be the best one. And if you go and split your network in 2 layers like this one or more, you're going to notice usually what you're going to do is not to improve, but to decrease the performance. But play with that. Play with the number of layers. Moreover, okay, playing with everything. One more thing that I want to add to that list of things that you can play using the library. One thing that we have not covered is how many times you use your data set for the inputs. Because help me, do you remember that we start with this example with the XOR? What our data set was something that had 4 lines, right? How many times we use the full data set to train the model? $10,000 times our data set. Okay, now remember that we did another one for the numbers, the one that we are working, the bad one with the images as an input, and we have a data set. I think it's a little bit longer. How many data we have there? And how many times we use the data set as an input? Remember? You can go and compare the source codes, and this one is 4, and we have this loop 10,000, and inside we have a loop 4 because we're using these rows this number of times. Here we have a data set that is longer, and we just take the decision one time. Can we use this one more times? Or can we use this one only one time? Remember what was the problem if we use this one only one time? Our model could be garbage. Only 4 inputs to train the equations, garbage. Okay, we did it 10,000 of times. But we repeat the same data. We do not have more data. So it makes sense here. We have a good amount of data. Can we use more than one time the thing? Hopefully you agree with me, like, yeah, it could be a very good thing to do. We use the data one time because we have a lot of data. And so far we move forward. But the idea, the recommendation is use your data not one time, but more. Take advantage, even though you have 60K of data. Well, the reason because you have 60K of data is because predicting whether or not this is a number, 0, 1, 2, 3, is more complex than you do the equation XOR. So yes, you have a good number of data, but you can run this more than one time. Okay, how many times you use the full data set have a fancy name? Oops. The number of times that you use the full data set to train the network is always at least one, but there is no rule that limits you to use only one. Do you remember that for the XOR, that was our source code? We can create these 4 loops that we have there forever. What happened in the case of the problem that we are solving here? What happened here in our model with this? I am sure that you remember this source code. It's the one that we have been using a lot. And I am sure that if you notice in your source code, you have this instruction, model fit. And I am sure that you notice that in model fit, you pass the data set. 2 options. Option number 1, you can have model fit, pass the data set, and you can put that line inside of a loop and just call model fit several times. That's what basically what we did with our XOR, a for loop enclosing the part in which we are doing back and forward propagation. How many times? It's up to you. I am calling this one 1,000 times. Option 1. Option 2 is like, I am sure that should be a better way to do this. Yeah. Fit. Second parameter. Second parameter, a number. The number, your number of epochs. The number of epochs, yes, how many times this method is going to run. Small detail. This guy and this guy. If this guy, the one that you are passing as a parameter to fit, is a data set, the data type is data set, you need to do the while, the loop yourselves. But I am sure that you notice that in your program, what we are sending and if you have a data set iterator, the only thing that you need to pass is the number because this guy is an iterator, and then I can go with this. Two ways to do it. This one with the number is going to fail if you just have a data set. You can put this data set in an iterator and then pass here as a parameter, or maybe you have the iterator for the beginning, like we have it. So we can use this one. But worst case scenario, you can do this one, is how many times you use the full data set. So far, the last attempt that we did, our model with nested up, with the initialization random, the ReLU, the softmax, the negative likelihood. I think this one was the last one that we create that give us something like 0.95, at least. We achieved this 0.95 thing. So our model is like, okay, it's working. It's working with only one epoch, with only one time reviewing the full data set. Do you think that if we move that number to something else, the model is going to improve from 0.95, 96, don't remember, to something better? You can get 98. And I just use 20 or something. It's another parameter that you can use to play. Did you notice the initialization of the W's, the activation function, the error function, the updater, and now how many times we pass for the data set? Those are the things that you can configure. And when those things, your goal is to make your model to have a good learning. Okay, now the problem, the question. Tell me, what could be the best value that I could put there in the epochs? Because in my for loop, I use 1000, and here I am using like 10, 15. So it's a very small value and a big value. What could be the best thing to do? A small one or a big one? Tutorials usually are going to use small ones. The goal of the tutorial is for you to learn something, not exactly to have a good model. A recommendation, a lot could be better. Here, if you run this data set those 15 times, is better than if you run only one, obviously. But here in our XOR, we use 10,000 times. A big number. How big? Or a small number, how small? Really, it is not about how big or how small is this number. The real condition is we are looking for some accuracy of 0.95 at least, or we're looking for an error that is below 0.5, right? it could be a good idea to check the model and instead of just put a number there like 10 or 10,000 or whatever, like have this feedback of what is the current error or what is the current accuracy, and basically ask the training to stop when we reach a particular value that we want to have. Because by the way, every time that you do the full iteration here is resources. So it's not exactly a good idea to do as many as possible. Moreover, your learning in some point is going to be a curve that is going to go flat. So you can continue doing iterations and nothing is going to improve. So really, you want to either reach a particular point or be aware that the things are not moving forward. So it doesn't make sense to continue doing iterations. It's better to stop. This is not going to improve better. Remember, your model, the quality, is about two things. Number one is the architecture that you defined before, the layers, the equations, and so on. And number two is about the data. So if you get a learning curve that is flat or the stop the improvement, what you need to do is to go back and check your architecture and maybe plan a different architecture. It's not anymore about data. It could be good to have this information. It could be good to have this information in real time, right? In our example with the XOR, we have this information. Remember that in the XOR, I asked you to print the information there or to do something with the information, create a plot. Did you notice that we have a problem with the library? Can I know about the error every time? Or can I know about the improvement, the accuracy every time? So far, what you have in your model is you finish the training and then you do the evaluation. And when you do the evaluation, you can have those numbers. What if I want those numbers before you finish the evaluation, before you finish the training? Because I want these numbers to stop the training. Software engineering. What we do if we want to check a value in a piece of software, in a class, in an object that is not mine. Huh? The getters, yes, but I can be calling the getter every second, and I am going to get the information for sure. Because I am sure that the model have getters for the values that I need. The problem is I am going to call the getters. What was the solution for that scenario in which we have a class that have some values that I need? Huh? Yes. And do you remember our friend observer pattern? Yes. And do you remember that the idea of the observer pattern is I need information that someone else has, but I do not want to be calling the getters again and again and again because of the performance. What I prefer is that the class notify me that something changed, and if that something changed, then I can use the getter. Do you remember in Java what is the other name for the observer pattern? We are going to have listeners for our models. We are going to have what we call model listeners. Model listeners, yes, we're going to be observing, listening to the object model. Remember that the object model is the one that you create using the configuration that we create as a parameter. Listeners to the model. Our model is going to be the guy there doing the updates to the variables and changing all these parameters and calculating things. And we need another object to have that information, or the same object. We can use that value to, in real time, plot what is happening in the model, in the training, or we can use to stop the training. We need the information. We need listeners. Listeners. 2 steps to use listeners. You remember what you did in listeners for the graphical user interfaces in Java? Do you remember that one thing that you need to do is add the listener or add the observer? Here, we do not have a method add. Set listeners. To whom? To your model. Which model? This model, the one that we have been using. This variable here, multi-layer neural network. That one, set listener. Now, my only recommendation here is in which part here do you want to add the listener to this guy, the model? Obviously, you cannot add the listener above this line, right? It should be below. Now, below, where? After or before the feed? Before. Okay, can we agree that the only limitation is put this before the feed? Why? Because if you put the listener after the feed, it's already trained. The information that you want is the information during the feed. So in any place before calling feed, so and after having the object, you can add a listener. A listener. Do you remember what is the parameter that you put for add listener or set listener or add observers? It's an object, right? An object. An object from which class? What?
There is no class.
One class, whatever, but that class should be an observer. And should be an observer. And do you remember that observer is a class, an interface in Java?
Yes.
Any class that implements observer can be a parameter for add observer. Set listeners. Any class that implements model listener is going to be able to be here. Okay, so this my listener is your class. Yes, this my listener is my class. Could be cat, dog, whatever. It's your class. A new object from that class. We are okay with the idea that I am doing that there, but it's like my listener x equal new model dot set listeners. Right? Okay. So this is the only thing that I need to do. Yes, this is the only thing that you need to do. The important part is we need to create a class. Can we use these here? Can you put like with the listeners of the graphical user interfaces?
No.
It's going to be a yes if the same class implements. Remember, just like with the graphical user interfaces, if the same class do the implements and the extent, good. If not, you need a class that have that. Okay, so better idea, software engineers, is to separate the classes, right? This using this is not exactly what you want to do. But using that, create an object, here the X, could be good. The only thing that I need to show you is the class my listener. My listener. Class my listener. Implement training listener. Why training listener? Because it's a listener during the training part. That is the interface that I am going to implement. And as usual, when you implement an interface, the only thing that you get is methods that you need to complete. Remember the mouse listener and all the methods that you never use but should be there? All the methods that you can use. I am not only using one, but you have a lot. Do we understand the methods and when they are going to be called? Because remember, I do the set listener. So this guy is connected with my model now. When this method is going to be called? Every time that I pass, complete backward, the backward propagation. When do you complete backward propagation? In the training model, like one time here or one time per row? When you complete every row, you are going, well, this method is going to be called. We're going to have the error one, but this one is for the gradient. What is this gradient?
The change.
The fancy name for the derivatives. Remember this derivative of the error function, la 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 la. When do you calculate that? Similar to this one, right? In fact, it's this one. After this one, if you're going to establish order. Forward pass per row when I am doing the evaluation. If you want to put these three in order, is the first thing that you do is with the input data of one row, calculate the values. With these values, you are going to calculate the gradient. And with the gradient, you are going to do the backward propagation to take the W's. 1, 2, 3 per row, but in different moments. This method can be called, this method can be called, this method can be called. Well, you can do something here. This one, epoch. We just talk about it, right? Epoch start, epoch end. Before and after. Epoch start, and you only have one epoch. Here you can get access to your W values, the original ones, the new ones, the ones that haven't been touched. Here, you can get access to everything after you complete one full pass, not in one row, but with all the data that you have in your data set. This one could be useful. But also, iteration done. Iteration done, what we're going to call an iteration. Pass for the data. Oh, wait, so I can use this one, but I can use this one. The problem is here you have only the model and here you have more data. So your choice. More data, don't worry. We need to review what is the more data. And among other things, the number of the iteration. I do not have here the number of that. I do not keep here a counting of how many times I have run. The only information that I have is I complete a full pass, a full epoch. Above, I complete the full epoch, but also I am counting how many times I am doing this. Okay, look like this one could be useful for some kind of review or evaluation. The others also, but looks like these values per row could be a lot. These values or the epochs are good, but this is better. I comply with that one above. What do I need to do in my listener? The only thing that you need to do is to provide all the methods because you're implementing the interface. And then whatever you want to put inside, like your mouse listeners and action performance and so on, put your code. Okay, let's see. What I want to do is every time that my model complete an iteration, so review all the data, I would like to have this printed. And I am just playing with variables just to show you that you can put your own variables. you can store things, plot things, communicate things, whatever, and you can have instructions. Your model here is being trained, and this class here is observing your model, and in particular, is receiving the full model as a parameter. Remember that the observer receives as a parameter the observable or the subject, and therefore you can call and ask for whatever you want. The model, and the model has several getters. One of them, use one, is this method score. And as you can imagine, score, yeah, the one that is related with the performance of the model, the last one, the error function, how things are going. I can ask for the model dot score, not randomly, but every time that I finish an iteration. Or I can ask every time that I finish an effort. Or I can even ask every time that I do a back propagation. Up to you. The idea is you have access to the data. Can we plot in real time the performance of the models that you are training? Yes. You only need to use here a library for the plotting, and that thing insert in a data structure, and the data structure is the thing that you're plotting, and done. We can do that later, but so far, the only thing that I am going to do is printing. And if I do the printing, you're going to get something like this in the model that I showed you before. From 2, looks like it's improving. Now, remember, these values are not aligned. Those values can go up, down. You are not looking for a particular number because here 0.7 is very good, but then we are here in 0.3 again. So remember, you need to flatten things. Values. Here, the only thing that I'm doing is printing. Can we use this value to calculate something like whether or not this curve is getting flat and then stop the training?
Yes.
Good. What can you do to stop the training using, for instance, this value?
Calculate the variance of last 10 values.
I am going to give you the example with, if this number is a particular value, then stop. But instead of that particular value, you can call a method, and the method can do a more complex operation. But how do we stop? Even if it's with one value. It's not a problem of machine learning, it's a problem of software engineering. Can you agree with me that basically we need to be back here?
Yes.
And something that we can do, not the only solution, but the trivial one, is okay, let's use this. And something that you can do is forget the for loop, because now we do not know how many times we're going to do this. So we can have here a while. And moreover, the condition for the while could be, what would you think about while? We have a problem. This is one class, but the listener is in another class. And you need to stop this class or this thing when a particular value or a particular condition happen in the other class. While, do you remember that the name for my listener was X or whatever? Whatever is the name of my object. Can I have a getter method? Or can I have a method? So can I ask the other class, my object from the other class, should I stop? and the other is the one that is going to return yes or no. Which means that if I can do this in this class, what should I do in the other class? Can you agree with me that you need to put inside of this class public, boolean, stop, and that one is going to return a Boolean value that is going to be a global variable? Okay, so the stop is just going to return the value for a global variable. Okay, but here, if model score equal to a value, or model score to a function, whatever, but if the condition happen, change the global variable to true. So the next time that this guy asks, this one is going to return true, and therefore the other is going to stop. Nothing related with machine learning, software engineering in particular is not about, I cannot do it because it's the library. You are going to always have, if you need to have access to something, getters. And moreover, if that something is like here, a loop, changing values, observer, look for the observer, search for listeners or observers are going to be there. So that means that, for instance, I am asking you to create these different versions, 3 models for a particular problem. You can really go and search for the best solution. You can really stop your training, not with only 1 iteration or 10 or 15, but you can continue more or less until you really found something that is good. Clear? Okay, now, this is what you're going to do. Box, listeners, and so on. One more thing that you need. What is the data set that I am going to ask you to do? And I am going to move to a very simple one. ID data set. Why I am choosing that one? One reason is a comma separated values file. And if you can do this one, then you can do a model for anything that is use an Excel file. That is the reason, period. Moreover, this one, do you remember how many rows do we have in this one? $100, 1,000, 10. A very small one. It's a small one, but it's a good one. You have 150 lines. How many inputs or columns? This is the data set. It's a picture of the data set, period. It's a file, a comma separated values. Your file, it is data. I put this one on Canvas if you want to use it. This is what you have. And the only thing here is use Excel. 1 value, 2, 3, 4 values that are floating point values. You have 4 inputs. In a summary, is to recognize flowers. And basically what you have is the size of the flower and the size of the lower part of the flower. So you have 4 numbers, 2 sizes. And with that, you recognize if the flower is type A, B, or C. And the flower is there. Really, with 4 numbers, we're going to recognize the flower. How many outputs? In that data set, 3 outputs. You have the flower A, the flower B, and the flower C. And the last column, as you notice, flower A is that one, flower B is this one, and the flower C is below. Okay. Step number 1, something that I did for you. This is the original data set. My recommendation is easy to work. We do not need the names. You can change the name for numbers. So you can replace that one for 1 or 0, this one for 1 or 2, and the other for 3 or 2. Your outputs in the data set are strings. It is better to work with numbers. So in the data set, in the data, you can replace the text for numbers. 3 outputs. Good. So with this information, can you imagine the architecture of your neural network? How many inputs? How many outputs? How many nodes in the middle? The real question is how many nodes in the middle, because at least you are going to have one hidden layer. How many nodes? Do you remember the rules, right? Can be 3 nodes? 4. Remember, one of the rules is a number between the number of inputs and the number of outputs. Another rule is less than twice the input. You need to fulfill all the rules? No. If you fulfill one, it's a recommendation. But remember, recommendations. This one is going to work well with a small number of nodes. It's not going to be like the previous one that we have 1,000. For the data set, step number 1, you need to read the data set, right? You need to put the data set in the memory. How we do that with this input? We need to remember how we did that for our example. Do you remember that for our example with the pictures, we create objects, dataset iterator, and in particular, we create 2, and in one we put 60Ks, in the other we put 10Ks, one for the testing, one for the training. Moreover, we established that yes, we want to make the pictures black and white or not. You can change these things here. But do you remember that we put this number here? Help me, what is this number 100?
Batch size?
The batch. What was that for? How many rows together? Because remember, one problem that we have here is 60K rows, put all of them in the memory and work with all of them is kind of not a good idea. I mean, we need to take care of the memory. So we are going to work with these guys 100 by 100. So we create this batch. Those 2 lines was the only thing that we need to load all the pictures for the digits. Can you imagine how to load the Irish dataset? Dataset iterator, whatever name you want to use, equal to new. Remember that this name is the name of the dataset. What if I replace with this, that is the name of the dataset, and everything else? Because the library is giving you methods to do work that you do not need to do from scratch. The library gives you these methods to load the data set for the digits. The library also can give you a method to get all the data from this data set. And something that is going to happen is not going to work with 3 parameters. It's going to work only with 2 parameters. Can you help me to know which of the 3 that I have above is going to be eliminated? Huh? The one. The color. Why the color? Because now we do not have pictures. I cannot put binary or not. First parameter, if you want to create batch, and the size. Second parameter, how many elements do you want to load? What if I told you that probably my parameters could be something like this? Only one thing and 150 total. Do you remember how many rows do we have? You can load all of them. It's 150 in use one pass. Don't worry, you're not going to do that. That could be the easy way, right? And if you want to load another of the data set that I mentioned to you before, probably it could be a good idea to start searching for the name of the dataset iterator. And use dataset iterator and give me all the API of all the dataset that I can load. And you can play with them. You do not need to do that for the class. For the class, I am going to keep use with this one. But option number one, easy. However, you are thinking, okay, this dataset looks like a Excel file, comma separate values. What if I have a data set from a different project, class, or problem that I want to use, but that one is my data set and is not going to be in the library to load, right? Okay, let's assume that the library do not have this method, so we can solve that idea of my own data. Clear? My own data. What do you do with your own data? Let's see, 2 slides. 1, if you do not want to use the method from the data sets that automatically are loaded, then step number 1, you need the data set in your computer. Because the methods that I show you, get the data set from the internet, get the data set in a connection remotely. But if you are not going to use those, then copy paste the file that I shared with you on Canvas to your computer, or you can get the file directly from the web page. It's going to be a text file, but the extension is going to be .data. And we are going to do the following things. Line number 1, new friend in the library, record reader. Do you remember the readers when you work with Java file reader? Okay, there is a class, record reader. Okay, record reader. And in particular, that class have a child. And the child is CSV record reader. Do we get the idea? Record reader, in particular, this one is for files that are comma separated values. 2 parameters. What are the parameters? The first one, a number, the number of lines to ignore. Why that is important? Headers. And sometimes the data set is going to have not only headers, but comments and other things. So you can put there a number that is 0, 1, 2, 10, whatever. You need to know how many lines at the top are not part of the values that you want to read. So in this scenario, for this particular example, the one that I shared with you, there are no headers. So my instruction could be 0. You are not going to ignore lines. All the lines there are data. This is for comma separated values. However, you can use any other delimiter, tab, white space, dot, up to you. But let's assume that we're going to use commas. It's the one that is in the data set. So 0, comma, and the character, comma. Easy. Next, that is an object. And the only thing that I am going to do with my object is to put that object to work calling a method. And in particular, I am going to call a method because remember, so far the only thing that I did was, hey, you're going to be an object. You're going to read these text files and you're going to separate them by commas and you're not going to ignore any line. And the object is there. Okay, I am going to do that. Call the initialize, and the initialize is going to have 1 parameter. Can you tell me what is that long parameter that I'm passing to this method? The file that you're going to work with. Class path resource get. That is Java. Nothing to do with the library and so on. The library is used, the record reader. The library is this, okay, Let's call initialize. And what you need is the file, but the file encapsulated in a particular object that I can use to access the file, in particular to do the split. File split. Do you remember that working with files in Java is working with streams? And working with the streams is one object is going to encapsulate another, that is going to encapsulate another, that is going to encapsulate another. That is the philosophy of Java working with files, with data. Here, we have the file, and the file is the parameter for a wrapper. That is our class file split, the one that is going to help us to split things. And that is the parameter for our record reader. And with that guy, the record reader, is going to be one of the parameters that we are going to use to create a data set iterator. Dataset iterator, this is the same one that we used before. But now, instead of being equal to a data set for that images or directly for the flowers, a record reader data set. And the record reader data set is going to have as a parameters those things. And I want you to notice, I give you this in green. One parameter, the record reader, the one that we create above, the one that take care of the delimiters and all the split things, la la la. And then it's an iterator. Numbers that I need to confirm, numbers that I need to provide, that we already know them. This. Do you remember what is these three numbers? What they represent? Total number of lines, total inputs for the features, total outputs for the number of classes at the end. With that, we have a dataset iterator. It doesn't matter if you do these two slides, this one and this one. What we have is exactly the same element that we have here. So having this is our path to train the models and to evaluate the models. Once we have this dataset iterator, we can do everything else that we have been reviewing in exactly the same way, no changes. Picture, the iris, and now hopefully any Excel file or data that you have in a text file, you can use it as an input. Can be as long as the 60Ks or can be used as small as 150 data. The quality of your network is going to be the difference. Now, something that is missing here, because, okay, now you have the data inside of a data set. What we need before I start doing the network. Something that you notice is I put all the data in one place. It could be a good idea to have training and testing because I have all my data in only one file and I just load the file. I would like to have two because here I have one data set iterator. In the previous example, I have two and I establish how many values, numbers, and so on. I want to separate. If I want to separate, the computer, the library can help me. Separate the data set, this one, in more than one. Let's see, you have an iterator. Give me the data. The method next give you from a data set iterator, the data set. Assuming that in this example, we load all the data in one. So we are not using epochs, we are not using batches, nothing. It's just all the data in one part. So one next is going to give me all of them. All the data. And I have a method in the data set that is that one. What do you think is going to do this method? disorganize your data. Why that step is important in particular for the data that we are loading right now? Because I am sure that you notice in your data set, all the flowers type 1 are here, the type 2 are here, the type 3 are here. So my data set is kind of in order, and that is a very bad input for training the network. Like you're going to train your network with only one type, and when you move to the second one, it's like the network is almost perfect for the first one and it's going to get lost. So you need to move things, and probably something that also is going to happen with any other data that you have. You are going to have some order because you are looking the data, humans. But for the computer, it's a good idea to. Did you notice that there is a parameter there? Like for what do we want a parameter for a method that is going to move things? I am going to move things, and I am going to move things randomly, right? Do you remember the method or the class random in Java? And do you remember that basically you have two ways to create random numbers in Java? One way is kind of the default one, but it's not exactly the best. And there is another one, the class random. And for the class random, something that sometimes you can do is to pass a value for the random numbers generator, and that value have a particular name. Yes. And what is that for? That one is the one that is going to be used to like create the randomness. And the idea is that this number is also random. So the randomness is really random. But also you can use exactly the same number here. And if you use exactly the same number here, your randomness is going to be equal to the previous randomness that you created.
Yes.
Okay, summary of random class, kind of. Okay. The correct thing to do there, usually something that you do for the random numbers, and you can use this here also, is you can use that system.current mylist. What is that thing going to do?
Current time.
You're going to use the clock to get a number, and that number is the one that I can pass to the randomness. So it's going to be random according with the number of milliseconds right now in time that I am running the program. And the probability of the milliseconds to be the same, obviously not going to happen. So every time the randomness is going to be really random. However, something that you can do when you are developing, instead of using the green one, that is the good one, you can put a number there. 15, 20, 42, 51. That number is going to help with the randomness, but the next time that you run the program, it's going to be exactly the same randomness than before. So while you are developing, it's going to be consistent, the random numbers, with the ones that you are using. So I put both options there. Up to you. My recommendation, put the number. That is going to help you for the debug later. Because you are not going to know if the randomness is helping to improve your model or to decrease the quality of your model. So it's a good idea when you are doing the testing of this for your homework to keep a solid number so the randomness do not change your results. Okay, so move the data. Another method, I have this method, split, test, and train. The name of the method is kind of descriptive. Data set, dot, split, test, and train. And what is going to do? Split, testing, and training data sets. Okay, but how? One parameter. One parameter, I put in green a comment. It's going to be a number between 0 and 1. 0, 0%, 1, 1%, 100%, 0.65 in this scenario, 65%. 65% what? Is the percentage of data that you want for training. And obviously the other number that complete the one is the number of data that you want for testing. Why you establish the training and not the testing? Because usually the training is the big one. So you use split. In this scenario, I am using 65% of the data for training randomly. The rows are going to be selected, which is something good. Okay, so that one, you are asking for a split. And when you ask for a split, you are going to get an object that object is from this class, split, test, and train. They are not the data set yet. It's an object that encapsulates the data set that you create. Think about this like an object that is encapsulating two linked lists.
Here's some information.
Thank you. Now, what you can do is from that object that encapsulates both, get the training and get the testing, and those are, again, data sets. These two slides work with any file that you have comma separated values. Good? Now, with that, your homework is you can load the data. And once you load the data, you can create a model. And when you create the model, you can test your model. Right? I want you to create 3. I want you to describe for me those 3. Obviously, I am asking for 3. One that is good, really good. One that is bad, the worst that you can create. And something else in the middle. Do not need to be 50-50, but something else. So at least I am asking you to play with 3 different configurations for nets. And hopefully those 3 are going to be good, bad, and medium. If you get 3 goods or 3 bads, look for something else. I mean, try to improve at least one. 3 models. Play with all the factors that we have been reviewing, including the epochs. Very good idea to use the listener so you can stop the training in a good place. Remember, at least the 0.05, you can search for that. And I am asking you for a paper. In the paper, I want to know about the architecture of your net. The architecture, remember, the configuration that you use. But also I want to know about the training part. Training and architecture in a paper. Show me your source code, obviously, your networks, but also show me how do you evaluate. Show me the confusion metric, or show me the values for accuracy and F-core and so on, or put a plot in which you are showing me how the learning curve is moving. I am open, but show me that you are really evaluating the model and understanding what is happening and what do you consider good, bad, or medium. It's kind of a summary of all the things that we have been doing in the previous week, now playing with the library. Clear. All of that in a paper, and again, the IRIS dataset. You can find the solution online. There are hundreds of solutions for this. Please do your own work. If you submit a convolutional neural net that is going to be perfect, we haven't covered that yet, so it's going to be hard to be like your homework. Also, you can search and check the values, and maybe you can use those values and put those values in your model and just prove that those values are really good. All the options that we cover can provide very good results. You are going to have a hard time creating a bad one, a really bad one. Easily you can get something in 0.6 that is bad, but not so bad. Play with the things that we have been using. Show your expertise, play with the library. Clear so far. One more thing. You know what? So far, I am asking you to create a model, test your model, have a good model. But so far, what is going to happen when you turn off your computer is that your very good model that take minutes to be trained is lost. A very good thing to do, something that we need, is to save our models. Now, tell me, save a model. What is exactly the meaning of saving a model? You are not saving the picture of the network connected and so on. What you are saving is the value. You are saving your values for the W. You are saving your values for the bias. You are saving your values, so on. You can go and get those values and save the values by yourself, or the library can help you with something like this. Do you remember that your model have the init method, the set learning rate method, the set listener method? Well, there is also a method Same. With one parameter. A file object, which, among other things, establish the name of the file in which you want to save your model. Okay, if there is an instruction to save the model, there should be an equivalent instruction to load the model. And hopefully this gives you the idea as follows. So far, your programs are training models. In some point, you are going to have a good model that takes a lot of time to train, and you're going to save that one. And the only thing that I need in another piece of software, someone else not related with your neural nets and so on, the only thing that I need here is load the model, and I can use the model. And I don't care about all the training stuff. Even I don't care about the architecture that you use. I am only going to open the model, and opening the model, then I can call the output method, sending a particular input, and I am going to receive the output without having a knowledge of the architecture of the model. So I can create a piece of software that is smart, intelligent, or adaptive, using a model that I do not create. So right now we have a models trained in Java. Something that we need to do is using those models in applications that probably we can create also in Java and see what happens. I stop here. You have homework. See you next week. Thank you.